खाना सब बढ़िया। Good evening, Yukta.
Good evening, sir. Sir?
Yes.
Sir, I have a doubt for the half yearly exams, like the mock tests which we have now. For them, like to write those tests, will we have the whole day time? Like 3 hours would be given for the test to be completed, but would we have the whole day time to do like whenever we want to give the test?
I think the timing is you should be submitting your answer sheet before 5 p.m.
Sir, before?
Before 5 p.m. you should submit your answer sheet.
Okay, sir.
So you should try to complete it today only or tomorrow morning.
So from today only we'll get the chance to complete it.
You can start the test today only.
Okay, sir.
Complete it within 3 hours and submit, or tomorrow morning. Because if
Okay,
you
sir.
suppose you start the test at 4 p.m., then you won't be able to submit it by 5 p.m.
Okay, sir.
Good evening, Sarvan. Yeah, so let's continue. Just waiting for, okay, I think almost everyone has joined. Okay, 3-4 people have joined, so we can start now. Just one more minute. We'll be starting at 9:05 sharp. Okay, so here I have some of the questions. You can just go through those questions. Others are joining. You can go through this question and think for the answers. You can think for the answers.
हेलो हेलो हाँ प्रियंका मासी बाहर है
दे दो Okay, let's start now. So I think we can start. So see, your first question is an assertion and reason question. Okay, so see first question. It says assertion is if the net external force on the body is zero, then its acceleration is zero. So is assertion correct? Yeah, is assertion correct or not? Yeah, is assertion correct?
Yes, sir. Assertion is correct.
Okay, your assertion is correct. What about this? Acceleration does not depend on force.
False.
Sir, it's false.
It is false. So assertion is incorrect. Assertion is correct, but reason is correct. So that is option C. For question 1, we have option C. Here A is true, but R is false. Now for question number 2, define balanced forces. So what are balanced forces? Yes, what are balanced forces? Yukta, what are balanced forces?
so the other forces which like their net result would be zero.
Forces which?
So the forces which were whose net like the net force would be zero. Acting the net force which is acting on the object would be zero, where both the forces are of the same magnitude. When they collide on an object, then the net force would be zero. That is a balanced force.
If a number of forces are acting on a body and their net sum is zero, then the forces are called as balanced forces. Then state Newton's third law of motion. State Newton's third law of motion.
Sir, every action has an equal and opposite reaction.
Okay, every action has equal and opposite reaction. Okay. For every action, there is an equal and opposite reaction. Very good. Now, for the short answer type, all the cars are provided with seat belts. Give reason. So, why the cars are provided with seat belts? Yes. Think of it. Why are cars provided with seat belts?
Sir, to reduce momentum.
To reduce momentum. Yes, to reduce momentum. But the correct answer here would be for the inertia of motion. Okay. To avoid the for the safety of the passengers due to inertia of motion. Whenever there will be a car accident, so passengers will tend to move in the forward direction. So their velocity will be opposed by the seat belts. Got it? Then see, a hammer strikes a nail with a hammer of mass 500 gram, moving with velocity 20 meter per second. The hammer comes to rest in 0.02 seconds after striking the nail. Calculate the force exerted by the nail on the hammer. Who's there? Yes, so find out this. How will you find out? A hammer strikes a nail with a velocity. A hammer strikes a nail with a hammer of mass 500 gram, moving with velocity 20 meter per second. Right? The hammer comes to rest in 0.02 seconds after striking the nail. Calculate the force exerted by the hammer on the nail.
So should we find the acceleration first?
Yeah, first we find the acceleration and then find the force.
Yes, sir. Sir, is the answer 5,000?
Yeah,
5,000?
5,000.
Yes, sir.
Okay, what's the mass?
So mass is 500.
No, see it's
No, we have to
500
convert
grams.
it into kg, right?
Yeah, convert it to kilogram. You need to convert that mass to kilograms.
Sir, so is it 5?
Sir, is it minus 500?
Yeah.
Sir, is it
The answer
minus
is 5.
500?
See, today here we have acceleration on this. Just 1 minute. So see, here in question number 5, the mass of hammer is given as 500 gram, but we convert it to SI units, which
Sir,
is
I
0.
got Sir, I got 5 Newton answer.
How many newtons?
5.
Okay, just let's have a check. So
Okay.
acceleration we get as v minus u over t. So which is equal to final velocity is 0 minus initial velocity 20 divided by 0.02. So this comes out to be negative of 20,000, right? Divided by 2, so that means negative 10,000 meter per second. So it was negative 2,000. That was negative 1,000, and negative 1,000 multiplied with 0.5, that gives us the force. So force will be equal to 0.5 times accelerations, that is negative of 1,000. So this is 500 Newton. Got it?
So won't it be minus 500 Newton?
Yeah, it would be minus 500 Newton. So see,
Okay.
acceleration that has been brought about, it is brought about in the hammer. Okay. So the hammer has a negative acceleration. So the force experienced by the hammer will be negative. That's minus 500. Then sixth question. A cricket player lowers his hands while catching the ball. Why? Why does he lower his hand while catching the ball?
Sir, to reduce the momentum of ball.
To reduce the
Sir,
momentum of ball.
to reduce
Yeah,
the change rate of change of momentum.
Yeah, to reduce the rate of change of momentum. Very good. So eventually what he is doing by lowering his hands, he is increasing the time in which it will stop. Okay, and as we know that force is inversely proportional, we know that force is inversely proportional to time. So what he is doing when he lowers his hands, he decreases time. So answer for this, he decreases, he increases time of stop. Increases time of stop, hence hence decreases force. Got it? Then derive the mathematical formulation of second law of motion. So this you leave. You start with question number 8. An iron sphere of mass of 1 kilogram is moving with a velocity of 20 meters per second on a cemented floor. It comes to rest after traveling a distance of 50 meters. Find the force of friction between the sphere and the floor. Okay, anyone able to get the answer for this? What will be the acceleration? Okay, see what all quantities are given to us. Can anyone tell what are the quantities given to us? Jitendra? Yeah, continue.
Sir.
Continue. Which all quantities are given?
So mass.
Mass is given. So what is the amount of mass?
So mass is 1 kg. Mass of ball.
Kilogram. Okay. Then what else is given?
So velocity.
Which velocity is this?
Initial velocity.
Yeah. So we know its initial velocity is
20
meters
meters
per.
per second.
Okay. What else?
So we are given distance.
Distance. So we write it as displacement traveled, which is 50 meters. Is there
50
anything
meters.
else? Anything else?
So final velocity.
Yeah. What's the final velocity?
0.
0. Now what do we want to find out here?
So force of friction.
Okay, force of friction. And to find the force of friction, we must be able to find its mass times acceleration. Got it? So what is the acceleration that we have to find? Now see which equation of motion will be used to find this.
So third equation of motion, v square
Third
minus
equation of motion. So now we use the third equation of motion. All of you use third equation of motion and find acceleration.
Sir, is it minus 40?
40.
Yes, sir.
See,
Like,
you
sir,
get
minus
v squared minus u squared equals to as. So v is 0 minus u is 20 square equals 2 multiply with acceleration. So acceleration is a and displacement is negative 50. So you get negative of 400 divided by negative 100, that is equal to a. Negative, oh sorry, not negative, it's positive. So you get a negative value only. Finally, you get a negative value here. So both the zeros cancel and you get your acceleration. So what is the value of acceleration? We obtain acceleration as minus 4 meter per second square. So force will be equal to mass multiply acceleration, which is 1 multiply minus 4. So 1 multiply minus 4 will be equal to minus 4 Newton. Got it? The force of friction is equals to 4 Newton. The negative sign indicates that the force of friction is always acting in a direction opposite to the direction of motion. Okay, let's do a few more questions. All of you, please solve these questions and get your responses. Speak up your responses. So here I have another one. I have directly opened the numerical questions here. So you can directly see the numerical questions. See. The first one, a body of mass 5 kg starts and roll down 32 meter on an inclined plane in 4 seconds. Find the force acting on the body. So what is the force acting on the body? Harshit? Harshit?
Yes, sir.
Yeah, what is the force acting on the body?
Sir, I got 40 Newton.
What?
40.
40.
Yes.
See, you need to find out the acceleration again. Okay.
So I found the
info-
acceleration.
Okay, what is the acceleration?
Sir, 8.
8. Okay, let's see what all
Yes.
information is given. Okay, so you have here mass of the object is given as 5 kilogram. Its displacement is 32 meter. Time is given as 4 seconds. Is there anything else that is given? Anything else that is given here?
No, sir.
It's written start, so I think it will be 0.
Yeah, it starts and roll down. So when it starts, its initial velocity is 0. So we use the second equation s equals to ut plus 1 by 2 at squared to obtain time, to obtain acceleration. So s is given as 32 equals u is 0, so this whole thing becomes 0. Then we have only 1 by 2 at squared. T is given as 4. So this is 32 multiplied 2 divided equals to a multiplied t squared. T is 4. So you have 4 squared. Here you get 64 by 16 equals to a. So 16 cancels. You have 4 meter per second square as acceleration. What is acceleration? So once you obtain acceleration, then you can find out the force, which will be equals to mass multiply acceleration. Mass is 5 multiply 4. That is 20 Newton. So Sharwan, did you get the same answer?
No, sir.
So what I think, you have misplaced something with 32 meter. You did not consider 32 meter to be the displacement.
Displacement, yes, sir. Yes, sir.
What did you consider 32 meter as?
Sir, I consider as initial velocity.
Yeah. So I just thought that you have gone wrong somewhere. Got it. Sampath?
Yes, sir.
Yeah. Yeah. What about your answer?
Sir, I did mistakes in the calculation, sir. And I took different equation. I didn't read the question properly.
Okay. Rayan? Rayan?
Yes, sir.
Yeah. What about your answer? Were you able to obtain answer for this question?
Yes.